Hi folks, welcome back to Integration Review Part 5. So we got cut off on the last part, but that's okay. We were setting up for this U-substitution. We tried it one way, and it didn't work out for us. So we tried switching our U's, and it did work out for us. And so what we were going to do now is actually substitute it. So I have the integral of, I'm going to write this separately, okay? I'm going to write this as 1 over cosine x cubed times sine x over 1 times dx. Okay, I think that might help us see the substitution a little bit better. So, everywhere I see the cosine x, I'm going to put a u. And everywhere I see the sine x dx, I'm going to put a negative du. So that is going to give me the integral of 1 over u cubed times a negative du. Now it's probably a good habit for us to start bringing any constants and signs right out to the front. I probably won't show that very much during the course of our work. So that's going to give me the integral, negative the integral of u to the negative 3 du. And now I can use my power rule. So negative 1 over negative 3 plus 1, u to the negative 3 plus 1, plus c. And that's going to give me negative times negative 1/2 u to the negative 2 plus c. Or let's go ahead and rewrite that as 1/2 1 over u squared, all right, because that u to the negative 2 moves to the bottom, plus c. And then our very last step is everywhere we have our u, we need to put back in what was originally there, or cosine x in this case. So 1 over 2 cosine squared x plus c will give us our final answer. All right. Let's try example number 10. So remember when we did talk about u sub in the beginning, we said we were looking for a function and part of its derivative. So I noticed that on the inside here, I have x squared plus x minus 3. And then when I take the derivative of that, it's going to look almost like this. So we're going to pick u to be x squared plus x minus 3. That gives us du equals 2x plus 1 dx. Now that matches everything perfectly, right? My whole integrand is color-coded, so I'm not missing anything. What this means is that I now have the integral of u inside of a square root du. And we want to know that that's the same as the integral of u to the 1/2 du. And then we can use our power rule. So power rule says I'm going to add a power. So 1/2 plus 1 is 3/2. And then the reciprocal of that is my coefficient. And because I don't have any bounds, make sure you have the plus c. All right. Almost done. We're just going to put back in our u. So everywhere I see a u, I'm going to put in x squared plus x minus 3. And this is perfectly fine as an answer, or if you're checking answers with other sources, they might be more picky and have it like this. Okay? But it's really important that you know how to go back and forth between those two versions. All right, let's take a look at the next problem. Okay, so example number 11, okay? This is something I would call a sneaky case. And this is going to be something we actually see a lot in 151, where our u is actually going to be the 4x, okay? The u is not cosine because I don't see a sine anywhere in this problem. So u can't be cosine. But u here is our 4x, okay? That means that du equals 4 dx. But when I look at the equation, I only have a dx. So what I need to do is take that 4 and divide it to the other side. So 1/4 du equals dx. That means everywhere we see a dx, we're going to replace it with 1/4 du. All right, let's substitute. So we've got the integral of cosine u times 1/4 du. Again, I'm probably going to just go ahead and start bringing the constants right out to the front. So I'd probably write immediately 1/4 the integral of cosine u du. Now, this is a pretty straightforward integral. We get 1/4 sine u, don't forget the plus c. And then our last step is to go ahead and put back everywhere we see a 4x, or everywhere we see a u, we're going to put in 4x. Okay? Now, these kinds of problems are going to be so quick, I'm going to expect you to immediately be able to go from here to here without showing me that extra work. Okay? So if that's not where you are yet, make sure you practice that so that you feel ready for the lectures for that first week. All right, let's take a look at example 12. So we've got the square root of 5x plus 7. So in general, if you see something inside a square root, that's probably your u. So u equals 5x plus 7. That means du equals 5 dx. I only see a dx here though. I don't see a 5 dx, so I'm going to divide both sides by 5 and get 1/5 du equals dx. Now, everywhere I see a dx, I can replace it with 1/5 du. So when I substitute, this will give me the integral of u to the 1/2, right? Because I have the square root. So u to the 1/2 times 1/5 du. Goodness. Again, I'm probably going to bring that 1/5 right out to the front and not write that extra step. So that's just something to be aware of. And now we can use our power rule. So 1/5 times u to the 3/2, and the reciprocal of that is 2/3, plus c. This is going to give me 2/15, and I'm going to put the u back in, 5x plus 7 to the 3/2 plus c. Or again, we could write this as 2/15 the square root of 5x plus 7 cubed plus c. All right, let's take a look at question number 13. Also very, very similar to number 11 and something that we're going to want to know how to do right away, okay? So without showing all the steps, here's what I want us to be able to do. I'm going to take the 3 out. So I have 3, the integral of sine of 4x. In my head, I know that my u is going to be 4x. And that means my du is going to be 4 dx, and then I'm going to have to divide by that 4. So that's going to give me 3 times 1/4 integral of sine is cosine, but it's a negative cosine, of 4x plus c, okay? And that would give you negative 3/4 cosine 4x plus c. All right? So again, that's the level I want us to be working at, that we can look at that, recognize it, and just divide away that coefficient right off the bat. But if we break it down a little bit, and we say u equals 4x, du equals 4 dx. Okay? This is where we might notice that I only have a dx here, so I have to divide that 4 away. And that's where that 1/4 comes from. Okay? So this 1/4 is this 1/4. And that's going to be something that, again, we want to be able to do in our heads. All right, let's take a look at one more problem here. So we've got the integral of 4 cosine x over 2 dx. So I'm going to bring the 4 out. Integral of cosine x over 2 dx. I want to recognize this as a u sub case, where my u is x over 2. So u is going to be x over 2, du equals 1/2 dx. And I only see a dx, so I need to multiply both sides by 2. So I'm going to get an extra factor of 2. So this 2 times this 4 is going to give me 8 times the integral of cosine u du, which equals 8 sine u plus c, which gives you 8 sine x over 2 plus c. Okay? All right, let's do one last problem here. Example number 15. So this, again, I want us to be able to recognize right away that we need u sub. So u equals 3x, du equals 3 dx, but that means I'm going to have a factor of 1/3 in the front of my integral. Okay? Because I only have to match my dx here. So I get 1/3 the integral of e to the u du, and the integral of e to the u is just e to the u. So I get 1/3 e to the 3x plus c. All right, so this seems like a good stopping point here. We're going to come back in future videos and take a look at more complex problems and also talk about what happens when we do u sub with definite integrals. All right, I'll see you there.